Hello YouTube, got a nice physics problem for you. So if you like planes and you want to know how to land one, well, I guess not know how to, but know when it is safe to land, I guess, or getting that perception. You can take a look at this problem here. So if you are our plane coming in with initial speed of 150 meters a second, and the runway is 1 kilometer long, and you are decelerating, obviously, because you are landing, what is the minimum value of k for the plane to land safely? Now, minimum value of k, where does that come from? Well, we're asking for an acceleration equation. It'll give you like a of t equals negative kt, which I'll write down in a second. But let's write what we're given numerically first. So we have initial velocity of 150 meters a second. We have our final velocity because we know it stops, right? If we want to land safely, the minimum value to land safely, well, we're probably going to want it to stop, right? So velocity is going to be 0. Our position, that'll be represented by x. Now, make sure to make units the same. We have 1 kilometer, right? So that's 1,000 meters. So we'll write it as 1,000 meters. Now, since we're saying that our final position is 1,000 meters, we have to define where our 0 position is. And that will be at the start of the runway of the 1 kilometer long. So we'll just call that x naught, which equals 0 meters. Now, a, we don't know, but we're going to be solving for. In time, we don't know. Now, this in red here is given. I think I'm actually going to rewrite it in black. Yeah, let's do that. So we have that now. So that's our given information. We're asked to solve for k. So, well, what do we know about acceleration? Well, we know it's the integral, or the derivative of velocity. So to find velocity, we take the integral of acceleration. And that would be t... Oh, 1 second. Okay, I was saying, so the antiderivative of negative kt would be negative 1/2 kt squared, right? You raise it to a power and divide it by that power, or raise it to 2 and divide by that number. And then you also have to add your plus c, but in this case for physics, it's your initial velocity. So then we're going to do the same thing with position. So it will be the equation for position. Take the antiderivative again, get so if you raise t to a power greater than 1 more than 2, you would get 3. So t cubed, right? But then you got to multiply 3 by that 1/2, but actually it's going to be 1/3 times 1/2, which is 1/6, times kt cubed, and then you multiply the velocity times time. And we have our initial position, right? Would be technically your plus c for mathematics, but since our initial position we're just going to say is 0, because we defined our coordinate system as such, then we'll just say it's 0. So now we got to do the math portion. So we just set up the equations, derived them specifically for this one. So how do we solve them? Well, we know that the final velocity is 0, so let's set the velocity equation equal to 0, and that's what we're going to be looking for. Our two variables, two unknowns, so we have k and a speed. A k and a time final. So we're going to be looking for both. We want to know how long it'll take and what that k value is as well. So moving things around, we solve for our values here. Oh crap, I just showed everything. You didn't see anything. So moving on, you solve for k, so that's what it comes out in green. So solve for k, because that's what we're going to be looking for in just terms of the variables. Don't plug really anything in yet, but now we want to know the final time at which the plane will land safely. How long will it take? So what I did was I substituted the k value into the position equation, right? Because that's where we're going to have our final position is going to be 1,000 meters, right? But we'll save the numbers for later and just continue solving for time. I think I missed a squared there. Yeah. Oh, no, I didn't because the 2's canceled. Okay, so then you pretty much solve for time once you plug the equations in, and you should get 10 seconds. And then you plug that number of time into the k equation, and then you should get 3 meters per second cubed. Now, why cubed? Well, because notice the equation for acceleration in black there is 3 meters per second cubed, or k times t, and if you multiply time times 3, that's 1 second, so that means you would cancel one of the cubed, or to make it meters per second squared. So that's kind of why that's cubed there. And that's our time. So you may be like looking at this like, why did we have so many formulas and not use numbers beforehand? I was looking at it the same way too, and honestly, it's like it's different. It's going to be, instead of just kind of plugging and chugging now, you're going to really have to be thinking about things, and plugging things all in at the end, plugging in the numbers that you know, and rather figure out how you can manipulate the formulas so you can understand them. That's kind of the difference here in physics. It will be different than you're used to, but it'll be worth it in the long run. So hope trying to practice by using formulas and manipulating the variables, and really knowing those equations to really understand what you're doing, rather than just being like, oh, I don't have this, let me use this formula, or I need this, let me use this formula, and then plugging in the numbers. You might make a mistake somewhere, and then it could hurt you. But if you really show what you're doing by manipulating the equations, that's doing physics. That's showing what you know. So good luck and keep practicing.